What is life? You perceive any change in your environment, you process, find out whether it is painful or pleasurable, and you act to avoid pain or seek pleasure. And finally, whatever you have done, you bear the fruit of that action. So, in perception, you classify events occurring around you as painful, pleasurable, or neutral. To neutral, you don't react, and that is called as habituation. To painful or pleasurable, you react with greater force, that is called as reinforcement. And your reaction keeps improving with either your experience or somebody else's experience who has taught you how to respond to a particular event. So, in experiencing or learning, you use your memory, and that is stored in your memory, and it is used when it is needed. So anything that is painful or pleasurable is event of interest, and that is worth studying and worth optimally responding to. In sense of health events, the events are: healthy becomes diseased, disease dies or is disabled or gets cured, and only these 4 or 5 events occur in relation to health. Now the arrows that you see here are transition rates. How many became diseased in time t? And these transition rates are either accelerated or braked by certain factors. And among the accelerating or braking factors, some are modifiable, some are not modifiable. For example, if you want to prevent normal people from getting COVID-19, you can ask them to use mask. So that means at least that exposure to COVID infected air is modifiable. So among the modifiable, you want to choose the most effective, the most accessible, easy to use, the least costly, and the least risky. And a collection of these modifiable factors would form guidelines which will control practice of medicine or health policy. And this is what the entire health system is engaged with all the time. To avoid the bad and seek the good of larger numbers, larger benefit, low cost, low risk, in an accessible manner. So the study of all of this is called as epidemiology, and epidemiology is basically defined as the study of time, place and person distribution of the event of interest. The first step in epidemiology is data collection of information about the event of interest. And the first question in data collection is, on whom are you collecting the data? So according to that, you divide the whole population into a source population, a study population, and a target population. The method of getting the study population from the target population is called a sampling frame. And the two things about the sampling frame is that you want to collect the sample in a manner that it is representative of the source and the target population, so that the results that you get from the study population are generalizable or externally valid to the target or the source population. And the best method of doing it is random selection, where every point in the source population has an equal probability of selection. So this is random selection. Also, the random selection should be of adequate sample size. You can't generalize results of 2 cases to 2 million. So there should be a sample of sufficient sample size. Now, what is sample size? Sample size is like a power of the microscope. It can make you see 2 points as different, which in a lower power microscope you will not see as different. So if you have a sufficient sample size, you will be able to see difference between 2 points, which you would not be able to see if the sample size is lesser. If the selection is not random, then sampling frame, how selected, must be precisely described so that any selection bias can be identified. And you should know exactly whom your results would apply to. What data is to be collected, on whom it is to be collected, and what data has to be collected. So, the data collected should be sufficient to answer time, place, and percent distribution of the event of interest. This is called as descriptive epidemiology. Here you are only describing the event of interest. The second thing is, you must find out factors that accelerate or break the event of interest, and these are called as risk factors, and such studies that associate the event of interest with their cause are called as causality studies. So, in some of the situations, you are not modifying the exposure to cause. For example, if you are saying smoker, non-smoker, and lung cancer, no lung cancer, so you are not modifying. So there is a etiological factor, smoking, and there is disease, lung cancer. Then there can be a prognostic factor. For example, if your immunity is strong, or if the vitamin D levels are normal, you are less likely to die from COVID-19. So this becomes a prognostic factor. So you are associating presence of or absence of prognostic factor with outcome. All these are observational studies. You are just studying the exposure. You are not modifying it. But in the third type, the treatment or the intervention, you are trying to modify the exposure or the risk factor. So such studies are called as experimental studies. And whether you will put a particular person in the study population in which group becomes an ethical situation. So ethics comes into it in a much bigger way. Finally, after knowing what is causing what, you want to find out then what to do. So these are trying to develop policy or practice guidelines. Now, you collect the modifiable factors, you find out the most effective, logistically simple, to be done with least cost and least effects, least risks, and you collect all these factors and you frame a policy or a practice guideline. So, this is what you want to do with your results. Then there are what are the characteristics of a good data collection? Because if you have not done a good data collection, your results cannot be good. First, it must be comprehensive. It must leave nothing. Secondly, it must be precise. That means no matter how many times, no matter who measures, you should get the same results. And thirdly, it should be it should be valid. It should be near the truth. For example, if your blood pressure instrument is saying that the diastolic blood pressure is 90 and you actually measure it through the artery, it should turn out to be 90. Because otherwise, if it is measuring 10 millimeters more, then it will diagnose many more as hypertensive than actually are. So it must be comprehensive, precise and valid. What is data? Data is a collection of variables. Variables, what is a variable? Variable is that whose value varies with each participant in the study population. Here. This is the example of data. First you have variable names. The first row, first column is identification, which participant, and then subsequent cells are the value that the variable is having for that particular participant. Now, variable can be categorical. For example, here you see that the blood group is categorical. Either person can be A, B, AB or O. And here what you can report, you can say how many A's, how many B's, how many AB's, how many O's. So if you can report only the frequency. So if you say there were 2 A's, it is not so valuable. If you say that out of 4, 2 were A's, it becomes relative frequency or proportion having A's, and that becomes much more valuable, because if there were 2 A's in this population, the study population out of 4, then 50% in the target and the source population will also be A's. So if you want to generalize, then you must have a proportion, you must have a denominator. You should never report a frequency alone. Then there are ordinal variables. For example, pain can be 1 plus 2 plus 3 plus. Here the value suggests an order. 2 is more than 1, less than 3. But 2 plus 1 will not make 3. So besides frequency, here the relative frequency, besides frequency and relative frequency, here you can also report the cumulative frequency. For example, 1 plus 2 plus 3 plus, here you see. Then you say 2 had 1 plus, 1 had 2 plus and 1 had 3 plus. But as soon as you put number 2 upon 4, 1 upon 4, 1 upon 4, then you can say that in the target population, 50% will have 1 plus pain. But then you can do what is called as cumulative frequency. Now cumulative frequency at 2 upon 4 had 1 plus pain. But 3 upon 4, 2 plus 1, 3 upon 4 had 2 plus pain or less. So in the cumulative frequency, you can say 75% will have pain, 2 plus or less. So this is frequency, relative frequency and cumulative frequency, which is the crux of a frequency table. So this we have covered that 2 upon 4, 50% is the relative frequency in the study population, 2 upon 4. But 50%, saying that 50% will have 2 plus pain or less, is the probability in the target population. So relative frequency in the study population is the probability in the target population. That formula you must remember. This is called as inferential statistics. And one of the most important thing is that here the number 2 of 50% is a point estimate. So it is in the study population, but maybe in the target population this number may be 2.3. It may not be exactly 50, it may be 53, 54. So if you want to cache the parameter, you convert this point into an interval estimate, 1.5 to 2.5. This is like a shotgun. The point estimate is like a rifle shot. It may hit, it may not hit. But this is more likely to hit. And as the interval goes on widening, it has greater and greater chances of it containing the parameter in the universe. And if the chances are 95%, then this is called as 95% confidence interval. So this next we will cover how do you summarize the data in the data column. How do you define the central tendency, the mean, median, mode? How do you define the dispersion, which is range, the standard deviation, the interquartile range, and the confidence intervals? This we will cover next time.